Hi everyone, my name is Gael Caron. I'm a simulation and modeling engineer for ADN company. Today, I would like to introduce to you the new ADN simulation platform that we offer to our client to deploy online the simulation program. This demonstration I will make now is to show how to deploy a Dymola model in online. So Dymola is the Modelica software owned by Dassault Systems. I will choose a simple model from the Modelica library. It's a mechanical model where we just control the motion of this inertia one here using this speed sensor and one PI controller, and we use a reference speed generation here that the system is supposed to follow. So it's a quite simple model. If we simulate this model here, we obtain that kind of curve. Is quite easy to understand. Here is the velocity of the inertia one. Here is the acceleration. So we know that basically if we build this model with Dymola, we have a Modelica program which is here. But the question for us now is how to make that kind of model available for a non-expert of Dymola, someone who is not able or to build a model or to use a model inside the Dymola software. So I will show you how to upload this model to our platform and how to set up that kind of model for a non-expert user. So first of all, we already simulate this program, so we will use the file that has been generated by Dymola when we simulate the program. So first of all, let's just connect to the platform. I will use my account to connect. Here. When you connect to the platform, you first arrive on the dashboard that represents all the model you can use, but for now we will define a new model. Okay, so let's define a new model. So let's call it inertia 1. You can add a description if we want. We just upload this picture that I took already, the DSIN text model which has been generated by Dymola, and also the dymosim.exe application file that has been generated by Dymola as well, and let's click on create. When it's done, it appears here on the manage view, and we can manage our model. We will start with managing the parameters. So in this page you can see we have three parts. The first one is the field of view, which are the field that regroup all the parameters all together. Then we have the parameters that are known by the model. It means the parameter that we would like to show to a user. And then finally we have the parameters that we can read in our DSIN text. So some parameters are already been had automatically to make it easier, but we can choose to remove, for example, some parameter that we don't want to show to the user. We will just keep the stop time of the simulation, the algorithm that we would like to use to solve the model, and the number of results for the post process. So now here we can see that we have all the parameters that we found in our model. So let's create, for example, a new field with the PI controller for the PI controller. So let's call it PI controller, and the display name will be PI controller as well. We would like to show to the user, so don't hide it, and let's click on create. Now the field has been added. So on the parameters that we can have, let's find the gain of the controller here. So we will add the gain of the controller. Let's give a range of value, and let's add this to the PI controller field. Okay, it's done. Normally we have also the time constant of the integrator block that we can also add. So let's say that we would like to have in between 0 and 10 seconds in PI controller. Okay, well, now we will add a second field of view for the mechanical part. So all the mechanics of the system. In this field of view, we will add the inertia of both 1 and 2. So let's add 1 first. The unit is already set up, description as well. Let's in mechanics. We can use the second inertia. You can notice that the inertia 1 is not seen here anymore because it's already added in our model. Let's add it to mechanics. And also we can add the damper value, damping constant value. Up in mechanics. What else? And maybe the spring constant value as well. Okay, so now we can see that we have 3 fields. One is the field for solving the problem, one is the field for the PI controller, and the third one is the field for mechanics. So now let's see what a random user for this model will see. Let's go back on dashboard and click on start working with our model Dymola Online Inertia 1. We will create one model, Inertia Test 1. Let's click on create and let's check the edit parameters. On edit parameters, you recognize the picture that I had, and you also will recognize the 3 fields that we define: field for the simulation setup parameters, field for the PI controller, and field for the mechanics of the system. Okay. So all the value has been set up with the initial value we gave, obviously, but the user can change according to the range. So for example, if I change here for 11 and the range is in between 0 and 10, I will have an error. Yeah, okay. so I have to uh, put it back to 0.1 for example, and click on save. So now we define how to set up the parameterization window for our model. Let's go back to manage the model, click on manage, and now we will define the variables. So it means the results that we would like to have for our model. So for example, we will compare the inertia 1 derivative of the angle, so this one, and we would like to add as well the what was the name, the integrator, which is the reference. So integrator dot y here. It's also radian by second. Okay, so we would like to have those two variables as the results. Let's go back to management view and let's manage the graphs. So you will see that two graphs has been generated because we added two variables, but we would like actually to compare both together in the same graph. So let's edit our graph. Okay, and we would like to add a new series. So for us, the second series will be time and integrator. So this is the reference, and this is the real. Save. Let's give to motion velocity, time, and this is the radiation by second. Okay, so now we obtain the two results in the same graph. We can delete this graph because we don't need it anymore. Well, now we can see that we define one graph for our model. As we are the owner of the graph, it means that this graph will be the reference graph for all the users. So as long as one user will simulate the model, it will have this auto-generated post-processing. So we can go back to the dashboard, and let's say that we are now a random user. So for example, let's connect again. So you can see here that this model is the one which has been generated to generate the graphs. And now we will simulate again the inertia test 1. So the simulation is done, the last simulation state is finished, and now we can access the result. As you can see, we access the result very easily and we obtain the same graph as we wanted to have. So it means that any user is able to use our model with this parameterization window and that kind of results. The user can also set up his home post-process if he wants or she wants, but at least as a first view he will obtain the graph that we decided. Well, we can obviously add more graph if necessary. For example, let's add another let's add these variables, for example, which is the acceleration. If we add it and we go back to the dashboard, we start working with our model, we create a new instance, inertia test 2, we simulate, and we access the results. We will have two graphs now. The one is the motion velocity and the second one is the acceleration that we just defined. Okay, now we can also download the graph. Now, how to deploy this model to other users? So, for example, I will go back to manage and I would like to add one user to my model. I will create on new, and for example, let's say that I wanna add user 1 as a user for this model. So I will just click on create user 1. Now let's log off and let's connect to the platform with the name user 1. So user 1 doesn't exist yet, so I will register. You can do the same as well. I will set up one password. Register. So user 1 now is registered, and as you can see, automatically the demo online inertia model that we defined for him is directly usable. You can click directly on start working, create his home instance of the model, my instance for user 1, and edit the parameters for our model. So let's say, for example, let's multiply the inertia by 10 for both and simulate. So done, access the results. Yeah, now it's a bit more difficult for the system to follow the reference. Okay, as we can see, that's totally physically acceptable, I would say. But if you go to manage model, the user doesn't have any model that is home, so he cannot change anything to the model because the model is not his property. So this video is now over, and I hope you enjoy, and I hope you can figure out how easy is it to deploy Modelica model generated with Dymola into the ADN simulation platform. Thank you very much for watching this video, and feel free to contact us if necessary. You can directly access the contact page in our website. So my name is Gaël Caron, and you can contact me at gaelcaron@adn.fr. Thank you very much for watching again, and bye.